Hello, my name is Ken. I teach chemistry and I have a page which is Chemistry for Beginners. The name of the page is Chemistry for Beginners. Chemistry for Beginners. That is the page I run. On the page, I teach some topics and I also do question and answer section. I urge anybody who is offering chemistry as a subject to look out for this page, like it, and follow it. From now hence, I'll be putting up videos on chemistry questions and answers, and I'll urge you to supply your questions to me. Let's reason together and see what we can do on the questions. So today I'm going to answer a particular question submitted to me by a student who is finding this question difficult on her own. So let us look at the answer to the question and then we see what we can do about the question. So now, today, I'm going to look at some questions submitted by a student online to me for answer. So this section is called question and answer section. So this is a section where we are running on this video for now. So this is the question. The question reads: compare the first, second, and third ionization energies of calcium and potassium, giving reasons for each of your answers. So that's the question that she wants an answer to. So in this case now, we are going to be looking at the first IE, second IE, and third IE of calcium and potassium. How do we tackle this question? By the way, what is IE? That is ionization energy. Ionization energy is the energy required to remove electrons from a gaseous atom to make it positively charged. So ionization energy, assuming you have an element or an atom A in a gaseous state plus energy to give us A plus in a gaseous state as well, plus electron as E minus. So this particular energy, here is the IE. seen that the energy was invested in order to pull out the electrons from the gaseous atom. Now, based on this question, there are some factors that actually affect ionization energy of any atom. Factors that affect IE. These factors are: one is nuclear charge. Nuclear charge is one. The next one is shielding or screening effect. Shielding or screening effect. The next one is atomic radius. The next one is orbital stability. And lastly is electron repulsion force. So these are the factors that actually affect ionization energy of atoms. So we all know nuclear charge is the same thing as the number of protons. Number of protons. So the higher the nuclear charge, the higher the ionization energy. So when you are comparing two atoms or more on the ionization energy, nuclear charge is a very important factor. Nuclear charge is a very important factor, all other factors remaining constant. Then shielding effect or screening effect is ability of the inner electrons to cover the outer electrons from the nuclear charge. So when the there is a lot of shielding on the atom, it reduces the ionization energy. The ionization energy will go down. Then atomic radius. The higher atomic radius, the lower the IE. So in terms of atomic radius, how does atomic radius affect ionization energy? How does atomic radius affect IE? Let's take for instance, if you have an atom, this is the nucleus of an atom, and on this nucleus we have shells surrounding the nucleus. So let's use blue color to denote the nuclear charge. Coming to this place, the nuclear charge is more pronounced at this particular shell. Then going to the next shell, we have another shell here. So you can see that the atomic radius is building up. Atomic radius is the distance between the nucleus and the valence shell. Then if we have another shell, so you can see how this nuclear charge is going down from shell to shell as the number of shell increases. So we expect that the electrons here will feel less effect of the ionization of the nuclear charge than the electrons here, while these ones here will feel more the most effect So the shielding, the nuclear charge of this will be more, of this atom will be more on these electrons here, and for that reason it will be more difficult to pull out these electrons because the nuclear charge is holding the electrons firmly, unlike these ones here. Unlike these electrons here can easily be pulled out. Hence, if the electrons there can easily be pulled out, we have a reduced ionization energy. The IE will go down because there is no much force of attraction for these electrons. So that is the effect of atomic radius on ionization energy. So the higher the IE, the higher the AR, the higher the AR, the lower the IE. So that is it. So the next factor which we have not discussed is orbital stability. The next factor is orbital stability. Orbital stability. That's the next factor. Orbital stability. It is more difficult. It is more difficult to remove electrons. It's more difficult to remove electrons from a stable orbital than the unstable one. So when an orbital is stable, electrons are more difficult to be removed from such orbital. How do we know stable orbitals? How do we know if orbital is stable? Orbital is stable. Orbital is stable. How to detect or how to spot a stable orbital? Orbitals that are completely filled, orbitals that are completely or half filled, are stable. So anything other than this is not stable, it's not a stable orbital. So this means that S S1 and S2 are stable because S will only contain the maximum of 2. So half of 2 is 1. So P3 and P6 are equally stable. Anything other than this, either of these two, is not stable because P complete number of electrons in p orbital is 6. So half of 6 is 3. So P3 and P6 are stable. Then when you talk about d orbital, d5 and d6, sorry, d10 are stable, while f7 and f14 are equally stable. I will make a video on quantum numbers to explain how all these values came about. So if an orbital is stable, to remove electrons from that orbital will be a very difficult thing. It is easier to remove electrons from unstable orbitals, that is partially filled orbitals than either half filled or completely filled orbital. So these are the things you should know. So if orbital is partially filled, if orbital is stable, that is completely filled or half filled, to remove electron from such orbital is very difficult. So that is what we should know. And also remember that I missed something. I also remember that in terms of s orbital, in terms of shielding, s orbital shields p orbital, while p orbital shields d orbital, while d orbital shields f orbital. So it is more difficult to remove electrons from s orbital. It is more difficult to remove electrons from s orbital while than p orbital, while it is more difficult to remove electron from p orbital than d orbital, and so on. So this is the effect of shielding as well. So s shields p while p shields d, and d shields f. So now, coming to the question the person brought to me, coming to the question that was presented to me for answer. So let us look at the question. The best way, or the way to tackle this question, is by drawing out the electronic configuration of the two elements. Drawing out the electronic configuration of the two elements. So calcium is atomic number 20. Calcium is 20, which has the configuration of argon core 4s2, and potassium, atomic number 19, which has configuration of argon core 4s1. The first ionization energy is the energy required to remove the first electron. So from the ongoing, we can see that calcium and potassium are on the same energy level, which means they have equal number of shells. So atomic radius or shielding effect will not play any role here, because they have equal energy level, which is 4. So which means it is expected that there should be 4 shells surrounding the nuclei of the two atoms. So there are 4 shells surrounding the nuclei of the two atoms. So 4 each for each nucleus. 4 for each nucleus. So for that reason, shielding effect, atomic radius is already constant. And in terms of stability, the two atoms have equal stability because they are equally stable, because the s orbital of calcium is completely filled while s orbital of potassium is half filled. So stability is ruled out in this case. Then the next factor that can help us in knowing which one has the greater first ionization energy is the nuclear charge. Looking at the nuclear charge, calcium is 20, potassium is 19. So for that reason, since calcium has more nuclear charge than potassium, so the first IE of calcium, the first IE of calcium is greater than that of sodium. So that of potassium, that of potassium. All right. Then the first IE is greater. Then let us look at the second IE. Second IE is the energy required to remove the second electron. So let us see what is going to happen at this point. So we know that at second IE, they are already in ionic state, or in ionized state. So second IE, calcium is going to be Ca plus, which means it's going to be argon core 4s1. That is second IE configuration of calcium 1 plus. So Then for potassium, this is K plus, is going to have the configuration of argon, so which is going to be neon core 3s2 and 3p6. So looking at what is happening here, even though calcium has more nuclear charge than potassium, because the nuclear charge still remains the same, the number of protons remains the same at this stage as well. So even though it has more higher nuclear charge than potassium, so which means it's expected that calcium should still take the lead. But let us see what happens at the atomic radius. Based on atomic radius, calcium has calcium has a higher atomic radius because the energy level of calcium is 4, while the energy level of potassium is 3. So, and we have already stated that the higher the atomic radius, the lower the IE. IE will go down. Even when atomic radius is high, ionization energy will go down. So, in this case now, potassium takes the lead because the atomic radius of potassium is lower than that of um, um, calcium. Again, both of them have equally stable orbitals, so stability is not a question here. It's not a factor that will affect this. Then let us look at another factor. It is more difficult, please note this, it is more difficult to remove electrons from completely filled shell. The completely filled shell is completely filled s and p orbitals. So when the s and p orbitals are completely filled, it is more difficult to remove electrons from there because that configuration is a stable state configuration. So by so doing, second IE of potassium, second IE of potassium takes the lead. Potassium takes the lead. Is greater than the second IE of calcium. And the second IE of calcium. So that is what we should know. Then, due to the fact that potassium has um, um, smaller atomic radius than calcium, so taking it closer to the nucleus, and for that, the nuclear charge should be more pronounced on potassium ion for the first ionization, for the second ionization energy. So that is what you should know. Then also another factor which determines or favored the IE of potassium to be higher than that of second IE of calcium is that the s and p orbitals of calcium ion are completely filled. So it has attained its stability. So this ion, is stable. Now let us go to the third IE. What happens when the third electron is about to be removed? So the third IE is going to bear the configuration of the second IE. The third IE is going to bear the configuration of the second IE. So now let us go. Calcium ion, that is the third IE, is going to be neon core, that is 18 this time around. Neon core 3s2 and 3p6. Then potassium is going to be neon core, that's potassium 2 plus in this case now. Potassium is going to be neon core 3s2 and 3p5. So from what is happening here, we can see that atomic radius is not going to be a factor here because the two ions have the same energy level. The two ions have the same energy level. So for that reason, atomic radius is not going to determine which one that has a higher IE than the other. So we outrule atomic radius. Now, what about orbital stability? What about orbital stability? Both of them can attain stability in the sense that by the time you borrow one electron from this place and give to this, it becomes 6, which is stable. That is to give to 5. You borrow just one electron and give to 5 here, it will become stable because both orbitals, s and p orbitals, are on the same energy level. So 3 3. So electrons can migrate from 3s to 3p. That is the excited state configuration. So you're going to migrate from 3s to 3p. It's possible. So if that happens, the 1s orbital is stable. I mean, the 3s orbital is going to be a 1, which is stable, while 3p orbital is going to be a 6, which is equally stable. So stability is not going to be a question here because both of them are stable. But then, looking at what is happening at calcium, it's like calcium is going to win this game. Calcium is likely going to win this game in the sense that this one contains 2. The s orbital of calcium is completely filled, while p orbital of calcium is equally completely filled. So making it difficult, more difficult to pull out electron from calcium 2 plus than K2 plus. So for that reason, calcium is taking the lead at this point. Then nuclear charge wise as well. Nuclear charge. Calcium has higher nuclear charge, more nuclear charge than potassium because they still maintain their nuclear charge. So for that reason, the third IE of calcium, the third IE of calcium is greater is greater than is greater than the third IE of calcium of potassium than third IE of potassium. So by so doing, I believe I have tackled the question of this dude. So now we are going to look at another question from another person who sent his question, but it's not going to be on this video. So as you watch this video, please try and like the video and also send your critics about the class. If there's anything that you feel that one or I should improve on this class, please, I will be glad and free to accept any critics on this video. So thank you very much, and may God bless you.